Now the next question is question number 3. Find dy by dx. Our first part is to calculate dy by dx with a given thing y is equal to x cos of y. Solution: y is equal to x cos of y, which is actually a given question. Differentiate with respect to x. Left hand side will become dy by dx, and on right hand side d by dx of x cos of y. As the right hand side is actually the product of two terms, x and cos of y, this is actually a given question, is an implicit relation or implicit function. Y is equal to x cos of y. So by taking differentiation with respect to x, that will become d by dx x cos of y. Now by using product rule, x will be as it is, derivative will apply on cos of y, plus cos of y will be as it is and derivative will apply on x. X into, this is into, a derivative of cos y will be minus sine y, and then derivative will apply on this angle, which will become dy by dx, plus cos of y will be as it is and derivative of x will be 1. Now we have to calculate dy by dx, and dy by dx is appearing on both of two sides. So first we shift into one side or left hand side, that will become dy by dx. This minus, after shifting to the left hand side, will become plus x sine y dy by dx, and on right hand side we have cos of y. By taking common dy by dx, that will become 1 plus x sine of y is equal to cos of y, and finally dy by dx will become cos of y divided by this 1 plus x sine of y. And the next question is x is equal to y sine y. The next part is x is equal to y sine y. Solution: let a given function is x is equal to y sine y, differentiate with respect to x. So d by dx on left hand side will become x, and right hand side derivative will apply on y sine of y. Derivative of x will be 1, and derivative, when we apply derivative on right hand side, so using product rule, y will be as it is, derivative will apply on sine of y, plus sine of y will be as it is and derivative will apply on y, which is actually dy by dx. 1 will be as it is on left hand side, and on right hand side y will be as it is, derivative of sine y. So derivative of sine is actually cos an angle y, and then derivative will apply on this angle, which will become dy by dx, plus sine y as it is, dy by dx as it is. And to calculate dy by dx, we have to take common this dy by dx from both of these two terms. That will become 1 is equal to y cos of y plus sine y. This dy by dx is a common factor from both of these two terms. And to calculate dy by dx, we have to shift this term to the left hand side, and finally we have dy by dx is equal to 1 over, this will be divided to the left hand side, that will become 1 over, or 1 divided by y cos y plus sine of y. So the next question is find the derivative with respect to x. We have first part cos with an angle square root 1 plus x divided by 1 plus 2x. So let y is equal to x cos of an angle 1 plus x 1 plus 2x, differentiate with respect to x. Left hand side will be dy by dx, and on right hand side d by dx will apply on this part cos with an angle 1 plus x 1 plus 2x square root. Again we have to apply differentiation of this trigonometric function first, which is cos, and derivative of cos is minus sine, as we discussed previously in previous questions. So derivative will apply on this cos, which will become minus sine, and then angle will be as it is, and then derivative will apply on this angle, like this will become minus sine angle, and then derivative will apply on this angle, which is actually itself a function, minus sine square root 1 plus x 1 plus 2x, and now derivative will apply on this f of x part, and this is actually exactly almost same thing which are the questions in exercise 2.3. So applying differentiation by taking or by applying power rule, we have 1 by 2 as a whole power, that is 1 by 2, and this function 1 plus x 1 plus 2x 1 by 2 minus 1, which will become minus 1 by 2, and then derivative will apply on this inner function, then that is actually d by dx of 1 plus x 1 plus 2x. And now this minus sign or this angle will be as it is, 1 by 2. 1 plus x will have to take power minus 1 by 2, and this 1 plus 2x also containing a power minus 1 by 2. We applied power in numerator and denominator separately, and now we apply differentiation on this algebraic function. Here we use a quotient rule. So in denominator 1 plus 2x whole square, denominator will be as it is 1 plus 2x, and derivative will apply on numerator, which is 1 plus x, minus 1 plus x will be as it is, and derivative will apply on this denominator 1 plus 2x. Now minus sign and this angle will be as it is, 1 by 2. Now this 1 plus 2x and this 1 plus 2x having same basis, so power will be combined, that will become 1 plus 2x power 2 minus 1 by 2. These two powers will be combined, and this 1 plus x containing a power minus 1 by 2, now shifting into the denominator, will become 1 plus x raised to the power plus 1 by 2. So in numerator, this 1 plus 2x will be as it is, derivative will apply on 1 plus x. 1 is the constant term, derivative will be 0, and derivative of x will be 1. So 1 will multiply to 1 plus 2x will remain same, 1 plus 2x, minus this 1 plus x will be as it is, and derivative will apply on 1 plus 2x. Now derivative of 1 due to the constant function will become 0, and derivative of 2x will be 2. Now our dy by dx is actually this minus sign, this angle will be as it is, and in numerator 1 plus 2x, 2 will multiply to 1 plus x will become minus 2 and minus 2x. This 2 will be as it is, and this 1 plus x can be written as into the square root, and this 1 plus 2x containing a power 3 by 2 after simplification. Now this 2x and this 2x will be cancelled out. Now we have minus sign with an angle 1 plus x 1 plus 2x square root, and in numerator 1 minus 2 will be minus 1, and in this denominator will be as it is. Finally we have dy by dx is equal to this minus and minus will become a positive term, sine square root 1 plus x 1 plus 2x, and in denominator 2 square root 1 plus x and 1 plus 2x raised to the power 3 by 2. And the next part is almost exactly the same thing which we simplified, or which we calculate differentiation in our first part. Just the change is in part 1 or first part we have calculated differentiation cos of an angle. Now we have sine with an angle, and an angle almost the same thing, square root 1 plus 2x and 1 plus x. I think you have to solve it yourself, an easy exercise. Y is equal to sine 1 plus 2x 1 plus x, differentiation will apply on left hand side dy by dx, and derivative will also apply on right hand side, which is actually like this, d by dx of sine 1 plus 2x 1 plus x square root, and then derivative of sine will be cos, angle will be as it is, derivative will apply on this angle. Now cos and angle will be as it is. Now differentiation will apply on this angle containing a power 1 by 2, so power rule will apply 1 by 2. This function containing power 1 by 2 minus 1 will become minus 1 by 2, and then derivative will apply on this inner function, which is 1 plus 2x and 1 plus x. Cos and angle will be as it is, 1 by 2 as it is, 1 plus 2x and 1 plus x both containing power minus 1 by 2, so applying power separately in numerator and denominator, and then we apply differentiation by using our quotient theorem or quotient rule. 1 plus x whole square, this 1 plus x will be as it is, derivative will apply on numerator, which is 1 plus 2x, minus 1 plus 2x will be as it is, and derivative will apply on denominator 1 plus x. this will be as it is. Now due to the same basis of 1 plus x and this 1 plus x, power will be combined. So 1 plus 2x will be shifted to the denominator with have power 1 by 2, and now 1 plus x and this 1 plus x, actually this is 1 plus x not containing 2, so we have 1 plus x only with power 2 minus 1 by 2, this 1 plus x and this 1 plus x, so there is no 2 actually. 1 plus x containing power 2 minus 1 by 2, and in numerator this 1 plus x will be as it is, and derivative of 1 plus 2x is 2, just because derivative of 1 will be 0 and derivative of 2x will be 2, minus this 1 plus 2x will be as it is, and derivative of 1 plus x will be just 1, because of this constant term derivative will be 0 and derivative of x will be 1. So now by simplifying, we have actually this one is dy by dx on left hand side, and on right hand side this cos and this angle will be as it is. Now multiplying 2 into x and 2 into 1, that will become 2 plus 2x and minus 1 and minus 2x, and in denominator 2 1 plus 2x raised to the power 1 by 2, so that will be actually can be written as in square root, and this 1 plus this was not 2, so we have 1 plus x raised to the power 3 by 2. Again 2x and minus 2x will be cancelled out. Finally we have dy by dx is equal to cos square root 1 plus 2x 1 plus x, and in denominator 2 with square root 1 plus 2x into 1 plus x raised to the power 3 by 2, which is our finally required derivative.